Today we're talking about graphing f of x equals a times x minus h squared plus k. So first let's start without the k. So in the first one, when we have a times x minus h squared, we want to look at what that h is telling us. So the h on the inside, when h is greater than 0, it is telling us a horizontal translation from the f of x equals ax squared. If the h is a positive, it's going to be a minus h. And just like we saw when we did the absolute value functions, the minus on the inside of the absolute value bars made it go the opposite. It's the same thing here. X minus h would make our horizontal translation go to the right. We usually think minus to go to the left. When h is less than 0, now this time when the h is less than 0, that x minus h would become x minus a negative number, which becomes x plus h. That is going to then do the opposite and push a horizontal translation now to the left of the f of x equals ax squared. So again, just like with the absolute values, that h on the inside, if it's a minus number, you're going to be seeing a horizontal translation to the right. If it becomes a positive or plus h number, it's going to be pushing it to the left. The other thing to note here is the vertex of this will be whatever the h is, comma 0. Okay, so again, if the h going in, for example, was 3, then my vertex in this form would be 3, 0. And this would also make my axis of symmetry that same x equals h, just like you see above. So in this form, and it has to be in this form, a times x minus h squared, when you see this, the vertex would be at whatever the h was that went in. So if it was a plus, it's now a negative number. If it's negative, if it's minus, it's still just the positive h, comma 0. Okay, so let's just look at an example here. So we're going to be graphing this function g of x. So g of x is in that form. So we want to look at a couple of things here. We're going to compare it to the f of x equals x squared. So first I just want to kind of get my major points here figured out. So as we just talked about, we're going to be seeing our axis of symmetry. All right, the 4 would be a positive number. So I know my axis of symmetry is sitting at 4. Okay, in this form, we would also know that the vertex is that same 4 for the x value, comma 0, because there's nothing being added at the other end to give us any kind of a vertical translation. Now remember, the 1/2 in the front is telling us that we are seeing an upward opening function, and then we want to make sure that we can figure out what are a few of the points that are surrounding that to make our graph. And then we need to find a couple of points to get started with our graph. And again, we're trying to streamline this a little bit without having to make a full table of 5 points. But we now know the center of our table is at 4, 0. So I'm going to use a couple of points. We'll just kind of stay here on the, we'll just focus on the left side, because I think in this case, the left side would make the most sense. So let's use x equals 0. And also x equals 2. And I'm using those even numbers because of that 1/2 in the front. So if x equals 0, if I was to plug that in, I would get 1/2 0 minus 4 squared. 0 minus 4 is negative 4. I'm going to square that to get 1/2 times 16, which is 8. So another point on our graph is going to be 0, 8. Looking at the other side, when I am looking at 2, when 2 goes in, I'm going to get 1/2 times negative 2 squared, which is 1/2 times 4, which is 2. So when 2 goes in, 2 comes out. So there's a second point. So let's just start making our graph. Now, I'm going to kind of try to make this as tall as I can. So I'm going to put this down here. We know that we're going to have both opening upward functions, so I think we're going to see both of these on the positive quadrants 1 and 2. So the first one, we know our axis of symmetry, or our vertex right now, is going to be at 4, 0. We had a point at 2, 2, and we had a point at 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now because we do have the axis of symmetry, we also know that those points would be on the opposite side at that same level. So I'm going to come off the graph a little bit here, but I can go to the opposite side to get somewhere in here. And remember to draw a nice smooth curve. Some of us were drawing on our last few assignments some kind of V-looking things. You want to try to curve it as much as you can to show that we are seeing a parabola, not an absolute value V look. So there is our function. This is the g of x graph. Then we want to compare that to the f of x squared. So the x squared one, if we hopefully remember, back for the previous lessons, we had 0, 0. When 1 went in, 1 came out. When 2 went in, 4 came out. And we can repeat those two on the other side. So remember, that one kind of looked like this. So that is the f of x function, the parent function. And then we're asked to compare the graphs. So comparing the graphs, we see that they both open up. We want to say that g of x is more narrow. It is wider. Remember that 1/2 is going to cause it to open up wider than the other function of a 1 in the front. And what else do we know? We know that the vertex has translated 4 units to the right. That is very messy, but that's what happens when I'm trying to write on this thing without messing it all up. So a couple of things. So we want to mention how they opened up. We want to mention one is wider than the other one. We want to mention that they both open up. And then the vertex, which has been translated. In this case, it's still at the y equals 0 level, but the vertex and actually the axis of symmetry have both been translated 4 units to the right. Next, we want to talk about adding this plus k. So now we're graphing a times x minus h squared, which we just did, plus k. Now, just like with the absolute values, just like we saw in the ax squared plus bx plus c, that number on the outside of those parentheses with the square is going to do something that we've already seen. This form is called the vertex form, which we will see why in 1 second. Okay, the vertex form is going to be something that's going to give us the vertex, which we want to make sure that that's very helpful to us. And the way that the h and the k are going to affect is we just talked about how the h is horizontal translation, and the k is now going to be a vertical translation. If it is positive, it's going to push it up. If it is negative, it's going to push it down. So now the vertex and the axis of symmetry could actually have a couple of different motions happening. The axis of symmetry could move left or right all of a sudden, but now we could also have that moving left and right, and the k moving it up and down. So the vertex of the graph, and this is where this is called the vertex form, is where we are looking inside the form at hk. Keeping in mind, don't just look at the h. If it is a x plus h, that actually means the h went in as a negative, and the k at the end, if it's a minus k, it's a minus k. Okay, and those would be your x and y's, which will right away give you your vertex. Okay? Also, just to keep in mind, the axis of symmetry is still going to be the x is equal to h, so it shows you where that is first as well. Okay, so now we want to graph a function that is in this form. So now we have negative 2, negative 2 times x plus 2 squared plus 3. We want to compare that to the parent function, f of x equals x squared. So again, we want to just notice a couple of quick things. We see that negative 2 in the front will be telling us that it's going to be opening downward this time. We want to keep that in mind. Okay, so a couple of things as we go through. So first, let's focus on our axis of symmetry. Well, the axis of symmetry, remember, is going to be the h in our function. So if I look at that 2 inside, this is the h. But in the actual function, it's minus h. And if it's a plus 2, that tells me that the axis of symmetry has to have gone in as a negative 2. Or again, a plus 2 does a horizontal translation of 2 units to the left. Okay? Now, in this form again, the vertex is hk. That is what my vertex is. So if I focus on my vertex, hk, in this function, we just said that the axis of symmetry is at negative 2, so that's the x. And the 3 is the k, so there is my vertex. So I know where my vertex is, I know where my axis of symmetry is. And again, the reason that we want to know this without just doing a blind table is now I can focus my table around the negative 2. So again, let's just pick a couple of points. So again, to try to keep numbers easily done, I'm going to pick negative 1 and 0 for x's to go in. So if negative 1 goes in, I'm going to have a negative 2 in the front, negative 1 plus 2 squared plus 3. That's going to give me 1 squared times a negative 2 plus 3. 1 squared is 1 times a negative 2 is negative 2 plus 3 is 1. So when negative 1 went in, 1 comes out. So there's a point. When 0 goes in, we're going to add 2, square it, add 3. 0 plus 2 is 2. When I square it, I get 4. And when I multiply by the negative 2, I get negative 8. So negative 5 comes out. So there's a second point. Okay, so I do want you to notice in this form, you can't say that the y-intercept is k, like we saw in that other standard form that we just talked about the last week or so. We have to just kind of follow the numbers here. So 0, negative 5 is what comes out. So this time we're going to have an opening downward one. So let's make the graph. So I think we're going to go here. And we'll make our x and our y's. Okay, when I plot my points, my vertex is at negative 2, 3, which is up here. Then at negative 1, 1, and at 0, negative 5. Perfect, right there. Now again, remember, my axis of symmetry is going right straight through the negative 2, 3. So if I just do the mirror image, there's my 4th point, and there is my 5th point. And again, as much of a nice smooth curve as I can, trying not to look like these, and it will be going downward forever. Again, comparing that to the parent function. The parent function had 0, 0, had 1, 1, had 2, 4. So again, I can just kind of do my mirror to get the parent function f of x. And I probably should write down here that this is g of x to label it. Okay, so g of x opens down. And again, we knew that from the beginning with that negative 2 out in front for the a. That's still the same. We also have the vertex translated 2 units left and 3 units So we want to kind of make sure that we notice that as well. And then lastly, this one should be g of x is more narrow. Again, that a value in the front being greater than 1, the absolute value being greater than 1, will cause it to open up quicker, which makes it more narrow of AV. Now again, we talk about domain and range quite a bit here too. So domain is still all real numbers. I know it didn't ask for this, but just to keep reminding ourselves. And the range in this case, remember, is going to be y is less than or equal to that 3, which was the highest point. So a lot of similarities between the quadratics, a lot of similarities between the absolute values. So remember that h on the inside is telling you your horizontal translation left and right. It kind of does the opposite of what it looks like. If it's a minus h, that means it's moving it to the right. If it's a plus h, like in this example, it's pushing it to the left. Then the k on the outside is doing the vertical translation. If it's a plus number, like in this case, it pushes it up. If it was a minus something, then it would be pushing it down. So hopefully this helps. Keep focusing on trying to be more efficient. In 8.1 and 2, we talked about a lot about tables and 5 points. We still want the 5 points, but we want to kind of move along and be better and then having to make a table every single time. So find that axis of symmetry. That centers your parabola. Find a couple of points on either side to find a couple of points, and then use that symmetrical mirror image to find the remaining 4th and 5th points. Hope this helps. And let me know if there's any kind of issues or questions, and we'll see where we go from here.